Hi kids, Miss Kulkarni here. I hope you are enjoying these videos about equilibrium and kinetics. Let's learn one more thing, and that's LeChatelier's principle. So what is it about? It's all about stress. Just like us, reactants, products and reactions also get stress. And what the system does? System tries to adjust by shifting the equilibrium towards reactants or products. Okay, let's keep in mind some other things. The equilibrium constant will be always a constant which will remain same, but it will be same at a particular temperature and pressure. What if we have different temperatures and different pressure? If these two are changed, then it's completely different story, and equilibrium will have a new value, and then reactants products will adjust to the new equilibrium constant. Keep in mind one important thing: catalyst is something which will always increase the rate of the reaction. So reaction goes faster. But what's the effect on equilibrium? No. Zip, nothing. It has no effect on the equilibrium. That means the equilibrium will not be shifting towards reactants or products even if we have a catalyst. Isn't it interesting? Alright, let's learn some more things about stress and releasing stress in a reaction. This table explains how the equilibrium shifts towards reactants and products when we make some changes in these variables. Let's have a quick look at that, and then we will go in detail with some more examples. Now, one thing to keep in mind is equilibrium constant, K equilibrium, is a ratio of concentration of products to concentration of reactants. So basically, if this is a constant number, you need to play around with products and reactants concentration. If you change one, we need to make sure we change the other one. And that's what it's about: adding reactant, how it shifts to more products, when we add more product, how we get more reactants, and all those kind of things. Same thing goes with removing reactants and products over here. It is just simply adjusting the ratio of numerator and denominator. This is about changing the pressure of a reaction, if of course the reactants are gases. So using the gas laws, what happens if we increase the pressure? The volume decreases. Now if volume is small, it will obviously try to occupy less number of moles of gases. So what we do? We find out the moles for reactant and also products, and then find out which one suits better for the new situations. Let's turn to endothermic and exothermic reactions now, and then how the temperature increase and decrease will have the effect on those reactions. Endothermic reaction is the one which takes heat in, and exothermic is the one which releases heat, or heat is exited. Now if heat is already exiting, will it like to have more heat? Probably not. So that will not be favoring the reaction. And same way, if endothermic is the one which likes to take the heat in, if you provide more heat, is going to favor. So we use some simple common sense, and we can figure out how the temperature change will affect the equilibrium, and we will discuss more about this in real examples. Alright, so here is our first example. This is a very famous process, Haber's process, in which we synthesize ammonia from N2 and H2. Let's get the balance reaction first. N2 plus H2 is giving NH3. When we balance, it should be 2 and it should be 3, I believe. Alright, let me explain this using this ruler. The ruler has left side, which is reactant in the form of paper clips, and right side we have products in the form of paper clips. Anytime we imagine adding more reactant, we are going to imagine having extra paper clips. And if we are removing or adding products, we are going to change the number of paper clips over here. So the first example is adding hydrogen. That is extra additional reactant. So if you have an extra reactant added to this side, what's going to happen? It's going to tip over like this. Now remember, our reaction is in equilibrium. That means this is not going to work. It is in stress right now and we have to release the stress. How the stress gets released? These reactants can convert to products, and when we get more products formed, it's again balanced. So what did we find out? When we add extra reactant, the reaction equilibrium moves towards products. Okay, let's do the next one. The next one is when we remove ammonia. Ammonia is a product. If I remove ammonia, this will be lighter side and it will be like this. That's not going to work. The reaction is again stressed. So what's going to happen? It's going to move from reactants to products and more products are going to form. So we get again the equilibrium established between reactants and products. And same thing goes with removing. If you remove reactant, this is going to go up. If it goes up, we are going to get from products reactants form and it will be the other side. So simply you can imagine this like a balance, and the two pans of the balance, you are adding or removing the masses and you can get the answers easily for all of those. Let's go back to our table and write down what we discovered. When we remove hydrogen, what happened? We ended up getting more product. When we remove ammonia, what happened? We ended up getting more products again. If you decrease nitrogen, then we are going to get equilibrium shifted like this. Less reactants here, more products. The system does not like the stress, so what does it do? The products go back to form the reactants and we again gain the equilibrium. So reaction shifts the equilibrium towards formation of more reactants. So let's complete that in the table, and that is reactants here. We forgot to add one more thing in reaction. Delta H is given -96. What does it tell you? That means the reaction is exothermic. And if it's exothermic, we write that heat on the side of products. So we are going to put 96 kilojoule right over here. So for an exothermic reaction, adding extra heat or increasing temperature does not work for forming more products. In fact, this will favor more reactants. Now let's talk about volume. Volume is increased. Let's find out how many moles we have for the reactants and products. On the reactant side, we have nitrogen 1 mole and 3 moles for hydrogen. Total 1 plus 3, we got 4 moles. And on the product side, we have only 2 moles. So if the volume is increasing, it's like having a bigger house versus having a small house. If it's a bigger house, you can invite more guests or you can invite more number of moles. So in this case, if volume is bigger, it's going to favor to have more guests. That means more number of moles, or that means reaction will be favored for forming more reactants. Let's talk about pressure. Pressure is double. That means it's increased. What happens to volume? Volume is less. If less volume is like smaller house, you will prefer to have less number of guests, and that is going to be 2 moles. So we will favor products here. About cooling reaction vessel. If you cool the reaction vessel, the heat which is given out will be easily removed. So more heat can be generated, and that means the reaction will be proceeding to form more products. Using this, can we complete rest of the table? Yes, of course we can. There you go. These are the answers for the amount of reactants and products when we go through all these changes. Let's figure out some important things here now. If you want to have lots of products, maybe we're having a business and then we want to get maximum product out. What is the best condition for us regarding temperature? High or low temperature? Look at the reaction. It's exothermic reaction. it's already producing heat. By increasing temperature, we are actually annoying the reaction, and that's why it won't like it. So it will give better results if we have it at low temperatures. Next thing is about pressure. Remember again, high and low pressure has the effect on volume. If pressure is high, what happens to volume? Volume is less. If it's a less volume, imagine it's a smaller house and you're going to invite fewer number of guests. That means you're going to prefer to have ammonia with 2 moles. So that's going to favor the products here. So this indicates we need to have low temperatures and high pressure to make sure that we get maximum yield and we can make some good business. Let's do one more problem for practice. Let's write the reaction first of all, and the reaction is synthesis of nitrogen dioxide from the elements. So it's N2 plus O2 is giving nitrogen dioxide, so it's NO2, and the balancing will be 1, 2 and 2. Let's use what we learned in the earlier problem. Increasing pressure, what does it do? Volume decreasing. Smaller house, how many moles we got? 3 moles for reactants and 2 moles for products. It's going to favor obviously fewer guests, that means it will favor products. Heating reaction vessel, what kind of reaction we have? 68 kilojoule is the heat and its positive sign. That means it will be on the reactant side and it will be an endothermic reaction. If it's endothermic reaction, it needs heat. So heating reaction will actually be favoring products. Cooling reaction is opposite. So we don't need to actually even discuss that because you can figure out that will favor reactants. Decreasing volume, volume goes down. It's a smaller house. We're going to again prefer fewer guests, that will go to the product side, which is 2 moles. Removing NO2, let's go back to our ruler. This is our product side. If you remove NO2, it goes like this. Reactants will go and form more products. Adding a catalyst, we know already, it has no effect on the equilibrium. And then decreasing nitrogen by half. Go back to again the ruler. When we decrease nitrogen, that's the reaction, it is like this situation. So what's going to happen? Products are going to go back to the reactants and then we get again everything settled. So it will be more reactants formed there. Let's write down that. We can easily complete the table if we understand the shift is towards products or reactants. Like first 2 reactions are giving shift towards products. That means we will have increase in products. In case of third reaction, shift is towards the reactants, so we get more reactants. In case of fourth reaction, we are getting more products, and so is for the next one. Alright, there we go. Those are the answers for the reactants and product concentration when we change those variables and reaction gets stressed. Let's talk about what are the best conditions for getting lots of products. In case of temperature, we have to figure out if it's high or low. Let's go back to our theory. It's endothermic. It likes to eat more heat, or heat is taken in. So obviously if you heat it or if you increase the temperature, it's going to love it and you're going to get more product. So high temperatures will be favoring the products. Let's talk about the pressure now. The pressure increasing will have effect on volume. Volume will be decreasing. If there is less volume, it's like small house is going to prefer to invite fewer number of guests, and we have 3 guests for reactants and 2 guests for products. So which one will it prefer? It will prefer to invite products. That means reaction favors the products here. So we are going to love to have high temperature and high pressure if we want to have lots of products and get good yield with this reaction. So look at this. If you are considering a business of synthesizing nitrogen dioxide, you got the secrets. We can use high temperature and high pressure, and we can make tons of product and we can sell it, and it will be highly profitable. So there we go. I hope you guys enjoyed the video. I will see you again soon. Until then, bye.